Hello to my one theoretical viewer. Bonjour. So here I am. I got new specs. I don't know. Nice and nerd-like. And yeah, very exciting. I've got... I've got some work to do today. I have to finish the C++ stuff that I was doing last time. We have this whole I2C device situation that needs some work, so needs some thought and development. So I'm going to do that. And then after that, I've got it set up to so that I can actually start trying to take a look at the power consumption of this thing. Yeah, I've got a bunch of cables and whatnot set up. Forgot to plug in the USB bank thing. Okay, that should be fine for a bit. And then, yeah, so I've got, well, I can kind of show you. I gotta set up the scene for this, actually. I haven't done this. You can kind of see it here. Let me make this big. Like that. Yeah, so I've got this supply. And then the idea is, instead of using a battery, and then using another battery, and then using another battery, I can just pretend that this thing is a battery, and set it to 9 volts, like I would a battery, and then run it through the... I gotta grab it, but the bucking supply. And so drop that down to 3.3 volts, which is what the thing wants. And in the meantime, I've got these multimeters. I don't need both of them, but I have them out, where I can attach the power supply through the multimeters and see like how much current is being pulled from this battery. And that'll give me an idea, like, can I actually deploy this? And how many batteries would I be going through and how often? Yeah. That's where I'm at. Let me know if you have any questions. I'm going to edit the stream info here, and then I'm going to blast off, I think. So first, I'm going to say, developing compost bin monitor, C++ify, and C++ify, then what? Then, once it's C++ified, then power circuitry, we'll say that. I'll put C++ in the tags. C++. And done. Alright. Still in the same category, but whatever. Let's see. I wonder how bad it would be if I set this thing to a higher quality. The camera frame. Because it is pretty bad. Let me try that. Hopefully I don't kill the stream here as I do this. Video capture device properties. I think you're good. Android webcam preset, we're going to say high. And I'm going to say okay. And that blows it way up. Yeah, that's fine. I think there's a shortcut to center it. That's Control D. Then make it bigger. 32 pixels on either side. 16. We're gonna Zeno's paradox our way to success. How's that? Oh, a little too big. There we go. Snap, snap. Oh, snap. Okay. Alright, so I can turn off studio mode now. And then this whole thing is now taking up the whole little frame. Cool, cool, cool. Wiggling it. Get it down to the right width, and boom. Cool, 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 cool. What is this frame? Oh, that's the screen capture for my own laptop. I don't know that I want that around, but I have it, so that's good. That's good. We'll keep it there. You couldn't see what I was doing there, but that's okay. All right. So now we have that. That looks pretty good. I'm gonna do the post for today. I guess I'll do that with Emacs. Why not? Use the scratch buffer. Let's see. And then I can just post it rapidly to all three. What are we saying today? What did I say last time? Let me see. Let me just do kind of a template here. It's Tuesday again. Tuesday again. No problem. Come watch. Let's code. We're modularizing a an I2C subsystem, and then working on the power supply for the compost bin probe. Modularizing I2C subsystem, and then later, let me make this slightly bigger font here. I think I've been making it a little. I think it's okay if you actually are getting like the higher quality version of the stream. Like I think it's not too bad. But then I was watching back some of the VODs on YouTube, which I figured out how to get them all published now, because they're not really marked properly. My fault. I was playing it back on some of them, and the text is absolutely illegible in some places, so make that slightly bigger. That should be good. I'll have to change my default font, I guess. Let me do that. Let me first, let's finish this. Let's code. We're modularizing the I2C stuff. We're I2C subsystem. We'll say I2C components, code components, and then instead of we, I'll say I'm we're. What's better? I don't know. Which sounds weirder? I think we sounds weirder, but maybe that's better. I don't know. And then adding more. And then we're gonna get it powered via a fake battery. Again, no problem. Let's code. Let's develop more of the compost bin probe. Let's develop more of the compost bin probe. Join me in developing more. Join me in developing the compost bin probe. First, we're modularizing the I2C code components, and then we're going to get it powered via a fake battery and possibly a real one. I won't even commit to that. Live from 2 to 6 p.m. Hashtag embedded. Hashtag live coding. Hashtag I don't know. What else do people use? I don't think there's. I haven't done this before because I'm a fool. But let me go on Twitch.tv and I'm gonna look for embedded system. Am I really the only one? I think I might be the only one. That's kind of cool. 0 views, but you know. That's cool. I guess it's good to be the owner of the space a little bit. I gotta be better at it, but that's encouraging. So I don't know what hashtags people use then. Live coding. What else is going on Twitch.tv actually? So don't start playing stuff. How do I make it not do that? What's in the software and game development category? We got programming in Go, Gemini update, Java course, There's some game dev, lots of game dev. C++ game dev, Unreal, Fortnite, some Minecraft mods. That's cool. It's all very cool stuff. I'm not seeing any embedded though, so that's cool. What about if I look for maybe low level? Let's see, low level. No, that I think that means like level, like game player level. Oh, you can't see any of this. Oh, let me do it this way. Whoa, whoa. Okay. C++. Just me. What about embedded development? Embedded computing? Embedded systems? No. Okay, let me add those. Why not? Embedded systems. Microcontrollers. It's just me. I'm the only one, so that's cool. Yeah, so I guess let me just grab what's on my stream then. For this. So embedded. We got programming. We got software development. Embedded development. Live coding is something I did for this. But then we got hashtag microcontrollers. We'll all lowercase for that one. And then we'll do hashtag C++. Twitch. Oh, and I need my on Twitch. Say done here. Twitch.tv/my channel. Is that correct? HTTP twitch.tv/me. It's got a www. We'll use the www. And then I might have to trim some of these once I go try to actually post it. So, Blue Sky. New post. Paste. 31 characters too many. Okay, let's get rid... If we're doing programming, I don't think we need to do software development. That's very long. And then if we're doing programming, I guess we don't need to do live coding. We'll get rid of that. I'll just do programming, embedded development, microcontrollers, C++. Or maybe sort embedded first. Hashtag programming. Okay, so then I can take this now. It's complaining about the spelling of modularizing. That's a word. I'll contend that's a word. I'll die on that hill. Why not? Now on my Mastodon account, we'll do that. Paste. Yeah. We'll post that. And then finally on X, post. And I'm more characters over here. So I'm going to get rid of those and post. There we go. Awesome. And then for anyone who's wondering about the reference, Tuesday again, dog. This is like my favorite meme from like 2014 or whatever. Know your meme. This guy. Tuesday again. No problem. Okay. So let me CD into... I'm already there. All right. So, yes. So, let's see. Compost mon. What does Git say we're at? I have a bunch of stuff staged. Okay. Yeah. Why isn't this a commit already? Did I forget? I must have forgotten last time. Commit. What are we committing? We are committing... What changed? Oh, I must have done this off camera. Is what happened. I already did it, so we're gonna go straight into the power stuff then. Whoops. Yeah, so I guess I can explain what I did. For your sake as well as mine. So let's see. Let me swap these windows around here. So we had to add... I split off the I2C code that was in there, which is right here, where we were directly using like the drivers from the ESP, the development frame, the IoT development, IDF. That was being used directly here, and so we don't want to do that. Usually for libraries where they're taking over something low level like that, you generally want to wrap them, because in a real device, a real application, that's the kind of stuff. That's like the first thing to change is like, oh, the bill of materials is too expensive. We're going to go with this other chip. And it'd be nice if it didn't have to be the same like family of processor or whatever. And so if you're relying directly on like the Espresso application libraries, you're going to tie yourself to those in a way that makes it really hard to move away from them. So the easiest thing to do is right at the start, you can prototype whatever, but then put that behind a level of indirection, a level of abstraction, and then you're using your own code as the interface to the hardware. So if you need to swap out something, you can swap out at a lower level something that provides a clearly defined interface, as opposed to swapping out like components that are core to your feature set and application. I hope that I explained that in a sensible way. But yes, so rip out this stuff, and we're going to wrap it into these three things. One is an abstraction for the actual I2C bus as a collective, and then there's the components on the bus. Each one gets to be its own device on the bus. So the display that we have is one thing, and then the temperature and humidity probe is another thing. So they get their own files. So let me jump straight to I2C bus.h and show you that here. So this isn't as isolated as I'd normally make it, but just for simplicity, since I'm not likely to change processors for this project, but it is modularized and wrapped up in its own thing, is basically we just have the I2C bus as a wrapper around what we get from the IDF framework, hold a piece of that, and then essentially allow you to attach individual I2C devices to a bus that you're given. And the way we do that is, for example, like this. We just call the function. Grab the handle, pass it all the config it needs. And this code should be familiar because it's the same code basically as what was in the main file. We've just put it into its own module now. So then we can do something like with the probe. Each of those commands becomes individual functions. And we implement them the same way they were implemented before. But now we can be more general about how it does the transmission. We don't have to call like a low-level thing ourselves. We're going through our I2C dev wrapper. Makes sense? Let's see. I meant to do this before. I'm gonna up the size of the font a few notches. We'll go 14. There we go. Okay. So let me commit this. Create a module for the I2C. Create a module to wrap I2C components. And then splits off I2C as a bus and individual I2C devices. And then also creates modules for the devices represented on the bus. Cool, cool, cool. All right, back to here. All right. So that's pretty much all we wanted to do in terms of this stuff. Let's see. Yeah, now instead of just one main file, I can show you how main has been simplified overall. We still have this function here to do the non-volatile memory stuff. It's kind of a one-off. It's a single function. It does these things and then you're done. So I didn't bother making it into its own module. Similarly with the chip info, like you're just grabbing stuff. If you have to rip it out, at that point you can add an abstraction pretty easily. And then same thing with like uploading the actual measurement. That's really high-level application stuff. And then if this application ever grows, then you can start doing like modularization of this and like making it more complex to support how more complex what it does is. That was a weird sentence. Okay. Yeah. So, the non-volatile memory stuff, this just makes sure that the flash that is supposed to be empty is empty and that it's initialized and ready to be read. Then we've got our blinky pin, which is just pin 7. Kind of a really basic abstraction, but this would be more useful as its own module if it were, if you had components that like were represented by, or software level components representing hardware that is like a collection of different pins, and then you can start manipulating those collectively as one unit of abstraction for the hardware. We've got our ADC. ADC it comes in various forms. This one just is the kind of one-shot form. where it does a single measurement, rather than, I think the other form is just like a continual measurement thing. We don't necessarily need or want that, so we don't worry about it. Wi-Fi is its own subsystem. The reason I've made start its own thing is that it like kicks off a different process and event handling and all that kind of stuff, and that's not really at home in the constructor of Wi-Fi service. And then SNTP it's how we do, where'd that come from? SNTP service. I think that's also in Wi-Fi service. No. Where is it? Where did that end up? Is it in Wi-Fi service? Yeah. So split that off into Wi-Fi service, but is its own global function, because it relies on Wi-Fi service, but we don't use. You can see here we don't use it, but we make the dependency explicit. So you have to pass it in, even though it doesn't use it, but it does use it under the hood. Here's our bus. We tell it what pins to use for SDA and SCL, clock and the data line. And then this true is for the pull-up config. We can look at that. I2C bus. If the pull-up is enabled, that'll turn it on. And then these are the devices that are on the bus. So these are communicating over the same bus as each other, and they have different addresses. And then you can start writing to them or reading from them in whatever higher level mode it is. So this way, you don't have to write like I2C write and then construct the command every time. You just do it the one time. And then the main loop. Toggle the pin. Oh, go to sleep for a while. However long you want it to be. This is in every minute currently. Toggle the LED. Do the one-shot measurement from the temperature probe. Read the moisture probe from the ADC. Do a little delay. The probe is a multi-step process. You have to kick off the measurement and then come back later. So we do that. And then we upload it to the server. Bada bing. So that's cool. And now it's time. I think I'm going to make this other display now. Let's see. How do I do this? Create new. I'm going to create a new scene. What should I call this scene? I'll call it workbench display. And what goes on here? So if I look at desktop display, the webcam frame, the input. Okay, webcam frame for my face. So scene, add existing webcam frame. That can be way smaller in the corner. Then I also need audio in this scene. You can't see this. I guess I could show you. Why not? Desktop display. I have this here. Oh, it just is behind everything. Scroll up. Go up. Properties. Application. Display. OBS. Yeah. There. Now you can kind of see what I'm working on. And I suppose I can... No, I can't do this live. Oh. Yeah. I can't do this live. But I can... Yep. Workbench display. Now you can kind of see more exactly what I'm working on. And then I'm going to add the Scarlett audio input, add the external Scarlett. Yep. And then what else do I need? The alerts, of course. There's an alerts frame. Where's that? That's way big. So make it that big. And it'll show up right on top of me. I'll put it up there. What else? I think you need the webcam. Or overhead cam. That's the one. That needs to be basically the whole screen. So that goes at the bottom. And what else? That's pretty much all you need. Let me transition. If everything breaks, you'll know. Alright, I think everything's fine. Cool. I'm gonna turn off studio mode. So here we are. Why is this bad? I thought this was high quality. Let me see. Video capture device. Setting is set to high. Yeah. It's not the worst quality I've ever seen. Oh, and the light is bad. Also, it's really blurry outside the center. Strange. Try to get more light in here. That helps a little bit. Okay. Get this nonsense cleaned up a little bit. I don't even know what this cable is for. Go away, please. Okay, and I should probably... it's already here, so I'm gonna build this, upload it, and then that should stay programmed onto the device. In the meantime, I'm also going to shift into the server directory and do Phoenix or mix Phoenix dot server, and that should start running that in a way that the probe itself can find it. Plug in the USB stuff. It's fine down there. Don't get too motion sick from me touching this thing. Okay. Now I just need to program this. So IDF-Pi flash. Okay. Now, I can actually turn it off. Okay, and the basic idea is that we're taking power from this thing, and then we're feeding it. It's not plugged in yet, but we're going to feed out from these posts. We're going to feed out from these posts onto this device, or the breadboard. And then that should kind of electrify the whole thing if we power the correct rails. Make sense? So I've got a few. Unfortunately, I only have a couple of pairs of these. Oh God, we're shaking. Don't look. No shaking. Steady. Steady. Okay, minor shake. Alright. I've got these. These are banana plugs. These guys. They fit right into those. And at least the way that these are designed, they like... You can see, you can plug in another set. I can stack them one on top of each other. Which is kind of cool. That's one kind. There's like the banana to bananas. More useful, and I don't think I found any other of, well, not more useful, but also useful. There are these with little grabbers. I don't know if you can see that, but you can like pinch them and press the little thing out, and there's a little hook. Very hard to see. There's a little hook that comes out the end, and that you can use to grab onto wires. So really, this is the end that we want. Interacting with the actual breadboard. I really thought I had other another set of these. Maybe I need to grab another breadboard and rewire this, because so some of the other breadboards also have posts. Like this guy. He's got posts here as well. He's got 4 of them. So I might choose to use this one instead. Yeah, let me do that. I'm going to rewire this thing. Oh, I'm sorry about the shaking. Unfortunately, like, this camera thing I have, I need to get, like, a real tripod for it. I don't know why I didn't think of that. Well, what should we start with here? One thing I can do, actually, is add... webcam? No. MacBook webcam. This one. Hi. Here I am. Put you over here instead of this other guy. Okay. Cool. And now you should be able to interact with me a little better here. Unfortunately, the mic is not a great spot for this. So, one thing I can do pretty easily is unplug the Sele bits, which you currently can't even see. But this guy, we don't need to probe it right now, so we'll just get rid of it. Simplify. Done. What else? These are pretty well understood. Let's see. This one, it says on here. Data line is green/blue. I know it's hard to make out. Data line, green, blue, VCC red, ground black, and then S clock is yellow or white, I think it says. Get rid of the screen. And actually, if we're going to optimize for power, we're not going to want the screen on there at all. What else? I can shift the whole thing over. Okay. I think that's better. Maybe. Okay, probe has been removed. And now we just have the voltage divider for this guy. I'll keep him here. And then this is part of the GPIO syncs the current through the LED. So I keep that in mind. But that's another thing that's like if power is a concern, we're not going to do that. And I never actually fixed this, but there is a bad ground pin. I have to remember that on here. And while I am at it, I should probably... connect some of the other ground pins as well. But I don't really have the jumper wires to make that happen right away, so I'll leave that off for a bit. So, I'm gonna swap out this board for that board. Oh God. Oh God. We got a whole lot of shaking. Okay. Come on. Stay. Stay. Good. Perfect. Okay, so wrong ones. We want the banana plugs. We'll just put them in directly into the doohickeys. I believe they're called posts. There we go. It's a little harder to insert than I expected. Okay. So that should power up all the rails. And one thing I should do is check with the multimeter, because this is quite an old thing. This breadboard. I got it in college, in my freshman year. So I'm going to grab my multimeter. And a pair of leads. Here's the other one. Okay, so I'm looking at it here. Positive is red into the top rail on all across the red bit here. Black, that looks right. And then it's going into these other guys. So I'm gonna turn it on. It's turned all the way down. And then I'm gonna just use that to check the voltage that we're seeing. And then make sure we're setting this to DC voltage mode. Should be very low voltage, so the 2 mode should be enough resolution. So if I poke it, overload. Oh, does that mean really only up to 2? Oh, because it's got more precision. I see. I see. So 2.3 something volts. Now we measure at these wires here that they're still sticking out slightly. That's good. I'm trying to stretch so I can talk on the mic. Okay, so that's good. Now I can try turning that down. Actually, one of the things about this very low-cost power supply that I bought at some point is, I don't know if you can see it, but the needle has not moved down. There you go, that's a better view. There. So you can see it hasn't gone down. One thing I like to do is just short it. That's easy. We'll just stick a wire in there. I don't advise this for anything with higher voltage, but this just makes sure any capacitors or whatever inside this thing are drained. There you go. Oh, it came back up. There. Is it gonna stay drained? Okay. So, where are we at? We have power coming in. That's good. Now we need the little regulator. I've got a bunch of... Oh, man. I'd forgotten I bought these. Oh, my prayers have been answered. I got a whole new set of jumper wires. Oh, man. Cool, I had foresight. Alright, don't need them right now. But I do need these guys. So, these are the voltage regulator things. They're still in their anti-static packaging. I'm gonna open this up. Speaking of anti-static, strapping in. There it is. So this is a little regulator. And I'm not prepared to do soldering, but I think I have to if I'm going to get this done. So I have these other like header things. I would like to attach them onto here so that then I can put it on the breadboard. The way to do that is with some pliers. Although, yeah, I'll do that first. And then see, because if the pitch on these is not right, if the holes are not the right distance away from each other, I fear that I'll end up in a situation where it won't fit on the breadboard. So I can test that out by just breaking some of these off. And if not, then I think I can cheat it a little bit by maybe just putting one pin on each of them. So each of these pairs on either side should be, each pair is connected to itself. So both of the holes on each side should be effectively identical. But yeah, let me grab my pliers. I don't know where they are. Not these. These are for cutting. These like angled pliers. These are closer to what I want. I thought I had some flat pliers around, but maybe they're not here. So I'll just grab from the edge the parts that I don't want to break off, and then I'll break off the other bit. You can figure out how to do this. It just takes a little bit of practice. You could see like it's ridged, so you can see the weak points. Just give it a little twist. Okay. So now I'm just gonna check. It fits right in there as a pair, so that's good. But then I need another pair to test the other side. So I'm gonna do it. And grab, and boop. And it comes right off. Sorry for the shaking. I don't want my laptop to like fall off the desk here. Hold on. There you are. Okay, so that works fine. You can see, kind of. It's kind of small. But the separation between the top and the bottom on the same side is the same. Now, the only other question is, like, so you put down those, and if it slides right in with minimal effort, then that's good enough, right? The question is whether the other side also aligns there. So now we break off another pair of these thingies. Easy. There. I think maybe not. I don't think this actually fits properly here. Let me put in the other pair and see. No, it's perfect. So that's good. Now I just have to solder it. I guess I'll go grab that. Hang on, you're still here. Oh. Hi. Let me grab my soldering iron for fun. And because I think we need it here, so give me 1 second. Oh, I totally forgot I broke this. Because I dropped it. Not the iron, but the stand for the thing. I'm gonna have to figure out how to get this back in there. I guess it's just like that. It doesn't actually hook in. That seems wrong. It feels like it should be in the middle. I remember it being more centered. But I could be wrong. Yeah, I remember it being like centered, not off to the side like that. So let me try to pull this apart. Again, because it came apart when I dropped it, so. Come on. Ow. Don't mind me. Whoa. Don't mind me. Just breaking everything. Okay. Oh, that's not even part of this. Okay. Well. That's not even connected to the part. Okay. So it just like fell out and it just needs a good twisting to be back into place? I don't know. I could have sworn it was all the way in there, but maybe not. Little twist. Okay. Well, alright, let me put this thing back together somehow. That wedges in. There we go. Click. Oh, hang on, I need water. And possibly... Oh, no, I have some water. But nothing with which to pour it. Hang on. Alright. Let me turn this off. And back to here. Hi. Let me set up the soldering iron. Okay, well, you can't see it, but it's there. Okay, and I'm getting some buzzing. my headphones. I don't know what that's from. I think I might have used the wrong bad pair of cables from my audio interface. Maybe. Oh, I've muted it. There we go. Well, if I mute it, it doesn't go away, so... Ah. Mic cable was twisted up. Okay, so... I've got my soldering iron here. I should turn it on so it warms up. There we go. Little holes for different tips. And then there's this guy. It's just like steel wool or whatever for cleaning it up. I need to bring this light down. So I can see what I'm doing. Although I don't want it to blind you. Too bad smell-o-vision doesn't exist, or you could definitely smell the iron warming up in the metal. Let me open this window. Okay. Let that ventilate. And I've got some lead-free solder. So that means you need a little bit of higher temperature on the iron. And I'm just gonna tin the tip. It's already tinned from last time. But yeah, add some fresh stuff. And then kind of the key is you want to warm up the pad and then add more solder kind of on the opposite side if you can. That was bad. I'm leaning in a lot, so this is actually very difficult. Hang on. I'm just gonna sit on the floor for this if I can maneuver it. It's the wrong tip. But we'll make do. There we go. Just leave some on there. Okay. I gotta sit back up. All right. Get that cool before you try to touch it. Good idea. Yeah. I really didn't think this through for today's setup. And why'd the bit rate drop so heavily? That's crazy. Yeah. Maybe I really should turn off Wi-Fi here. Hang on. This is probably gonna cut out. Hello? Are you still there? I've turned on Wi-Fi. Yeah. I think that's good. Okay. I'm gonna leave this window. Leave this window open. So the other thing we want to do now is to actually try to tune this thing. So really what I want to do is, instead of powering the rails like this directly from this guy, what I want to do is to take, I'll take this, pull it into maybe this section of the board here. Or I'm trying to think, because really what I want these posts to be connected to this directly, and then this to connect to the rails. So I'm trying to think of the best way to do that. I don't know. Well, for the moment, I can clean some of this stuff up. So get rid of my solder and these extra components. Move them out of the way. And then take some wires. Well, there we go. Let me disconnect this so that I can get it out of the way. Okay. That can go. That's trash. Okay. Clean. All right, and so now I can take this. I'll take the voltage from this guy and then not worry about rewiring it just yet. But we do want to measure what's going on. So I've got some more of these jumpers here that I'm going to jump from red. I think I want them to share ground. Let's see what I'd do before. No, they are separate. They are separate grounds, as it were. I'll take that on faith that it needs to be that way. So I'm gonna do that. Actually. Got a few of these shorter boys. Nah. I'll just use these guys. Gosh, sorry about the shaking. I'll see if I can invest in a tripod or something. Just so that it's like separate. Because, yeah, right now I have this like bendy arm that's not, it can't actually attach to this little coffee table that I'm using. So it's leaning against it because it's actually clipped onto a crate because the clip is really crappy. So it just like slips off. The phone is too heavy. This is just a phone being used as a webcam. Gonna plug that into the inside end. There's an arrow. Alright, so we got in to out. And then in minus is on the counting at the top. I'll drop it. So in oh, you can kind of see it from this side. The minus is along the top and the plus is along the bottom. Okay, and then we have as output. I'm just going to leave these two kind of sticking out a little bit. Again, minus is on the top. Nope, I missed. And now I can grab some of those littler wires. Got this little wire jumper kit. And I'll just grab like a brown. They're pretty long though. Let me do, yeah, we'll do an orange. And a gray. Well, let me do a white so it matches. So a white, I don't need black segments here. So I'll do brown for that. Okay, and I'm just having those stick out because I'm gonna grab the clippy things. These little guys. Grab them like that. And then I can connect those to my multimeter. Well, actually, the first thing I should do is measure the output and set it to 9 volts so it looks like a battery. Getting all tangled up here. Okay, because the supply is kind of crappy, and it just has lines on it, you can't really see that. It has lines on it and very few markers. I don't really trust the accuracy of it, so I'm going to turn it on and use my multimeter to dial it in. All right, so that's at 2.34-ish. Remember, I'm targeting 9 volts. That's pretty close. A real battery is not usually going to be at exactly 9 volts for very long. In fact, it'll start to drop below that almost immediately. I think I'd have to do more tests on them to really know, but that's what I believe kind of how batteries behave is they start at 9, maybe 9.1, and then they'll immediately, as you start using them, begin to drop. So this is fine. So I think that's been dialed in. I don't have to do that anymore. That should stay where it is, even when I turn it off and back on again. You can see the voltage dropping a little bit. Let me short it out so it drops all the way. There it goes. And we connect. Okay. So now I need to start measuring the output of the regulator. So that's plugged in. That should be good. Okay. All right. Now I got to start dialing it in. So you can already see. So it's set to 9 volts. You can't really see it on the voltmeter on the supply, but it's already dropping at some. So there's a little. It's hard to make out in this image. But right next to where my thing is, you can see that little metal square thing. That is actually like a little screwdriver, little screw interface, like a potentiometer. So I can dial that in, and that should raise and lower the output of this regulator. And what I'm going for is 3.3 volts. So I can turn it all the way to one side, and that'll drop it a lot. Turn it all the way to the other. There's like a inherent drop, it looks like. So 7.85 instead of 9. All the way down. 0.81 or whatever. Really, I'm looking for 3.3. So I'm going to try to dial that in. I think that's going to be good enough. While we're looking at that, let's confirm something about it, actually. So, switch back to desktop display, and I got to pull up the data sheet for ESP32 S3 input voltage. Data sheet maximum, or here, power pins, absolute recommended power supply characteristics, input voltage, typical 3.3, min 3, max 3.6. So I could maybe dial it up a little bit so it's closer to 3.3. It's actually really tough. Good God. All right, that's as close as it's going to get. 3.37. That's fine. And then, actually, one thing I can do is let me turn off the MacBook webcam capture. Remove. Yes. Okay, hopefully that helps with the bitrate, which is currently tanking. Sorry to my viewers. But yes, so now we've confirmed. Actually, I don't know why I just killed that webcam. Because I want you to see me from over there. So let me do that again. Video capture device. Create new. Webcam with my FaceTime camera. Hello. Very big. Oh, that's the wrong screen. So let me... We're on the workbench display. Add. Add my face. Where's my face? There I am. Hi. Okay. Now that we have 3.3 volts, we can start hooking it up to the actual device. So how do we want to do that? Well, I think I want to do what I said before, and maybe move it up to the top, and then just power one rail with it. So let me unplug this guy. Oh, you can't see me still. So he's unplugged. He's at 0. I'm going to rearrange a little bit of this so that this isn't connected here. Move those off to the side. Or here. Or here. Or even here. I don't know why that guy's still there. And then this gray can come out. Okay. Oops. So connect them in the tippy top, and then I'll use the ones I pulled out. From up here to actually connect it back in. So remembering negative is along the top of this thing. There we go. And then we can use, wish I could make it stop shaking. Then we can use this other rail as our main rail. There we go, and then another red one. Okay. So now you can kind of see from this rail, from the top rail, get rid of these. These are going to come in through those into here and then into here. So power this whole thing. And then we grab from that through the regulator down to about 3.3 volts onto this whole rail here. There's some stuff hooked into the ground of it. That's fine. Yeah, that means we can now try to set back up like the blinky and stuff. First, let's verify that this is still at 3.3 volts. Perfect. There we go. Little probe still going there. And then I will actually turn it off while I do this. So I want to connect the board. .3 volts into the rail. ground as well. Okay. Now it's connected to power theoretically, and there should be there's S clock and S data for the bus, and I have these, which also need VCC. So plug that in. And then, what did I say? Green was SDA. Yeah. Yellow's SDL. And then I can take, where's the other board, and recreate this circuit on here. So there's a voltage divider for the output of the analog thing, but then let me get the LED going first. So I could use a smaller thing than that. Maybe I can't. Okay. So that's power going through. Well, actually, if we're going to do that, we can just use the resistor. Then from resistor through LED, making sure it's oriented correctly. And then from there, I believe it's pin 7. There we go. Okay. And then, well, I won't do the voltage divider yet. I think we can test it without this. We should see the LED blink. I'll have to sit around for a minute waiting for it to happen. But that should be fine. Oops. I can't tell if it's working. I'm gonna have to wait a bit. I think I saw the LED flash, so I'll wait a minute and it should come back on. Holding steady at 3.3 volts. It's too bad we can't monitor it. I mean, I could, but I think that would ruin the test. Let me look that up actually. Here. Oh, that didn't work. There we go. Okay, so I want to look up the ESP IDF monitor serial. And see whether a serial terminal program which relays serial data to and from target devices, serial ports, some IDF specific features. Okay. So we might be able to see this P the FTTY something monitor. So I have to grab which TTY port this is going to use. I'm going to do it on the serial side of it. I don't know if that works. Okay, so in theory, that's connected to the COM side, which should not be like providing power or anything like that. There is an ACM0, so let's take a look. I don't know if it's working. It reset, and it printed Hello World. So I think it's running, but it's hard to say. What if I, well, why is caps lock on? What if I change the code so that it does the blinking more frequently? So let's see. This is a good, I guess this is a good time to do a new task, a new thread, even though we're going to throw it away. This is temporary. Free RTOS thread. Look it up. Timer task? No. Idle task? No. Let's see. Unlike vanilla free RTOS, users of free RTOS in ESP IDF must never call VTest or scheduler. Sure. app main function. Typically, users spawn the rest of their application's tasks from app main, but how do you expect me to do that? That's what I want to know. So, do I use a normal FreeRTOS task? Maybe? Let's see. Let's look at some code. Main and reduced bitrate like crazy. Is it studio mode that's doing it? Oh, maybe it's really struggling with the camera on the workbench display. Or maybe it's something else? What's going on? Is it like trying to do updates or something? Or is it because it's trying to capture itself? Let me get rid of it. Yeah, it's still... Still really bad bitrate. But why? Yeah, why? I wish I knew, because then maybe I could fix it. So this is still here. Why is it saying that OBS... if I stop sharing. There. Stop sharing? Okay. Why bitrate so bad? I don't know. I don't think there's anything I can do about it. All right. Onward. Yeah. Onward. Noise on my cable, maybe? I don't know. Network. Can't say. I don't want to debug it right now. So we want to create a task. How do we create a new task? So this is a task. There's another core. What does that mean? Print real-time stats. Print real-time stats. So this is a task. Ah, I see. X task create pin to core. So X task create. Create with caps? What is this? Maybe it told me right there and I just read over. If users are to place tasks obviously in external memory, you can use the following methods. Okay. Not exactly what I want. Is that overview? X ring buffer? Not interested in the ring buffer. What is it saying here? Ring buffer, ticks and idle hooks. What is a tick hook? Must provide this function. No. TLSP. Thread local storage pointers. No, I think I just want X task create. From FreeRTOS. Assuming it's vanilla enough. There's this programming guide. Yeah, X task create. There we go. Create a new task and add it to the list of tasks that are ready to run. Tasks use 2 blocks of memory. The first is used to hold data structures. The second block is used by the task as its stack. A task is created using X task create. Then both blocks of memory are automatically dynamically allocated inside X task create function. If you create it with static, then you must provide the required memory. Therefore allows a task. Okay, maybe that's what I'll do. X task create static because I do not. I mean, I don't know how much stack I need for the LED. It's not a lot, but I guess we'll leave it at default, at some kind of default thing. So let me get rid of that, and then we'll clear the pin. Start it cleared. The thing means on. We're active low. And then I will create a task called LED toggle task. And in this one, we will do... What is X task? I'm going to call X task create on this. X task create. Task function, LED toggle task. The task function, I believe, wants a parameter as a, yeah, void star. So there. Parameters. Key data. Params. And we're going to promise ourselves that this is going to be a GPIO pin pointer in 7. And in fact, let's not do a pointer. Let's do a reference because we can dereference the GPIO pin star static cast GPIO pin star rams. And then xtax create. Xtax create. We're gonna pass. Where's our? So we got task function, PC name. PC name. What is PC name? Descriptive name for the task. Okay. GPIO. LED GPIO. And then stack depth. Number of words to allocate for the stack. We'll say 100. Why not? Or not even that. Well, let's see. We'll do 128. 128 words. So I believe this is 32-bit processor. So 128 times 32 is like 4K. 128 times 32. Yeah, 4K. 4096. That's fine. That's perfect. That's a lot. It's way too much, but well, 4K words. 4K bits. So let's see, 128 times 32, 4096 divided by 8. 512 bytes of stack. I think that's plenty. GPIO pin, this is just a reference, so just a pointer, effectively. And then we do what? P7 dot toggle. And I'll do the delay until thing in here as well. So forever. Delay until, grab these. Every minute, not every minute. We'll do every 2 seconds. Get a blinky going. So do that. P7 up toggle. Make sure we clean it up out of here. Yep. Looks like that's good. Then we just have to finish the invocation of xtask create. Parameters. Something that get passed into the created task. It's just going to be pin 7. And I believe this needs to be static cast to avoid star if we want to avoid type errors. Next parameter. That's on the bottom here. Stack depth. Yep. Parameters. Yep. Priority. Those are constants that I don't super care about. So I'm going to use just this. Idle priority. Sounds good to me. And then a task handle. Okay. Task handle underscore T. Lead toggle. We'll do H lead toggle task. Okay. And then pass that in. It's an out param. Assign the return value here. X returned. What is X returned? Base type T. I don't know what. Who knows? Could be anything. Base type T. Task result. If task result is PD pass, or how am I formatting? Like that. Automatically is how. So we got a stack size. Not telling me what they're using. If it succeeded, delete it. I guess. I guess we want a not equals here. And then we would do... What's, How does it do the assertion in here? Let's take a look. ESP error check failed. ESP error check failed. These are functions. So ESP error.c. Oh. ESP, no. Source? Yeah, ESP error to name. Check failed? No. ESP error check failed. Yeah, these are just functions. So where are they? Let's see. Back over here. I'll CD into the IDF. ESP IDF. Get grep for ESP error. ESP error check failed. Should be in some C function. There it is. In the system. Components system ESP error.c. So system ESP system error ESP error? Yes. Check failed. Oh, it just calls abort. Is that its own thing? Like from the C library? Might be what it is. Let me do... I'll just do this. We'll do... Error launching LED blinky task rebooting system. Okay. But now there's this big loop that should never end. So I guess if we ever end up here for some reason, although I think the compiler should be smart enough to see that we never exit. Blah blah blah, what's it called? X task join or destroy? What is it called? Oh. V task delete. Wait, what? There was another one. V task delete with caps. I don't know what that is, so just delete. H underscore what's it called? H LED toggle task. Oh, come on. There. That'll never get called, but it's there. So now I can go in here. Well, kill this. Kill this. This can get disconnected. Can I flash over this serial port? I'm about to find out. What does that blue light mean? We're writing. We wrote. Monitor? Oh. Oh. Panicked. Exception unhandled. Window overflow. Oh no. Oh no. Task create. 128. Maybe keep it at 64. Let's do that. Wait. Oh, come on. I'm trying to hit the kill function, but it's not working. No! It's not complying. Escape? No. Control Q? No. Back to where's Control T, menu escape key. No. Anything press other than... Oh, okay, there we go. Okay, so it's not... It is not happy. Why? Okay, rebooting. ROM, ESP restart, yada yada. Entry, fuse, detected larger than size, using size in the binary image header. Guru meditation error. What is that? Guru meditation error. What the heck is that? Also used by varnish. Company had a product called a Joy Board. It was like a joystick, but operated with the feet. Like the Wii Balance board. Early development. So frustrated. A game was developed where a person would sit on the Joy Board, resembling a guru. The player tried to remain extremely still. The winner was the player who stayed still the longest. If the player moved too much, guru meditation occurred. ESP32. Okay. Do we need to try to pin it to the main boy then? What do we need to know about how it does this core stuff and how it shares memory? Let's see. Back up here. Create a new task. Add it to the list of tasks. Tasks use 2 blocks of memory. 1 block uses for data structures. One block is for its stack. If a task is created using xTaskCreate, then both blocks of memory are automatically dynamically outside of the task create function. Yeah. You can only use it to create a task with unrestricted access to the entire microcontroller memory map. Yeah. You can do restricted if you want. I don't super care. xTaskCreate. This function takes parameters, give it a name, a stack size, idle priority, handle. X handle is not null. Delete the task. Okay. Sure. Note. Are there rules then on what I can call from within here? Because this all calls the GPIO driver stuff. So let me see. Let's do a searchy search. We do S3. I don't want the latest. I want stable. And I want the GPIO set level. Actually, I'm not at all sure what it's trying to tell me here. So GPIO set level, sure. All right, not what I want, not what I care about. I have to see. Okay, initializing flash. And then what? I guess I should write. So it says hello world. Printf, writing or launching GPIO task. New line. Okay. Let me untether it. And then plug it into the USB side. DTY ACM 0 still there. I'll do flash monitor. Yeah, it claims there's still room in the binary. I didn't think I was using very much RAM at all. And I am trying to get it to use like minimal RAM. So what the heck? Waiting for download. Try it again. Okay, there we go. Alright, get rid of that. Try it again. And plug it on the right side. Yeah, plugged it into the USB end. Which I think is correct. Waiting for download. How's that? There's like a sequence you can press, I think, to make sure it enters download mode. Let me see. ESP32S3 dev kit download mode. Boot RST pin. Let's see. Boot mode selection. It says it should do something automatically for those. Oh boy. Reset. Reset. No. Boot. No. Waiting for download? No. Where? Not ESP tool. Come on. Get started. Let's see. Somewhere in here, this guy. Getting started. Okay. Reset button, boot button. Holding down boot and then pressing reset initiates firmware download mode through the serial port. Okay. Oh, no, that didn't seem to work. Where's boot? No. Okay, there's two USB ports. USB port, first full speed, what is it? As well as for JTAG debugging. I'm not sure. Okay. Launching GPIO task. So it gets at least that far. Then I can do initializing moisture sensor. And then I can do initializing Wi-Fi. Wi-Fi start. SNTP. Then I2C initialize. And then display comms. Or is it mad because... Well, let me see. If I get rid of this with the pin, does that fix it all? Nope. H. This. Get rid of all those. Try programming it again. And that should not break it if... Maybe the problem is just that the screen is not connected. But I don't know why it would crash like that. Oi. Is that it? Try it again. IDF monitor waiting for download. Let's see. Hard reset, microprocessor, blah, blah, blah. Works fine after hard reset. Shows what? Looks like a lot of people are having a problem like this. At least with Arduino. The phone. This is all related to Arduino. How did it end up working last time? Just reset, maybe? Why is this guy waiting for download? Nope. Monitor. Broken pipe. It's powered off. Okay. USB. Whoops. Waiting for download. What does that mean? ETS delay. Oh, have I really screwed it up or something? TTY ACM 0 monitor. How about now? Ugh. No. Yeah, what? Oh, whoops. I don't know what add dependency is. There it goes. Okay, so so something about creating another task is really failing. But what and why? Right, so this is a pointer. And that, so, instead of doing that, why don't we just do this? Do puts on. We'll put a dot in there. Create the task handle. Create this. Pass in a null pointer there. Okay, and then this does nothing really, it just sleeps. Every 2 seconds. Flash monitor. We're back in the death loop. Okay. Kill this. Okay. And try it again, having gotten rid of spawning the task. Are we out of RAM? Is that what's up? I'm doing a lot of printfing. ESP32 analyze RAM usage. heap in it a bunch of stuff we're not using. Even a at least I'm not. Not even with all this C++ crud. Right? Which is not very much. I think the only thing is, like, this doesn't use... If you look at std array, the implementation of it, this doesn't really use more memory than an array. Right? Maybe it uses some flash to store all these functions, but they're generally, like, really efficient and easy to inline. And all it does is an access like you would for any array, so it shouldn't be an issue. All right. Minimum free heap size. Oh, that's an important stat. Let's see. Where's that being printed? In my... megabytes flash embedded yada yada. Where is that? Who calls you? Init show chip info. Nobody calls it. Okay, that's interesting. So, I want that. I want init show chip info. Yeah, I want that. Show chip info. I moved it and then never put it back. All right. I'm wondering if it's somehow how we're doing. I'm guessing Wi-Fi is the most intense consumer of resources or whatever. Okay. This is ESPS3 chip with 2 cores, Silicon Vision, 2 megabytes of external flash, minimum of 300k bytes, free in the heap. Okay, so if I try, let me see, init, launch this task, which currently does nothing but sleep and put a string. And then maybe if I do if 0 here, jump to the end, end if, and then I want to test something out. So I'm just going to do a for ever loop that sits here and prints something out like the other one, but at a different interval. So delay until, I'll keep the last wake time and all that. I'll keep this. Maybe block it altogether. And then I'll put a semicolon instead of, I think in my other function it's a period. Yep. So I should see, and I'll drop this down to 10 seconds. Every 10. Yes. Yeah. So that should all be commented out effectively. Oh, and so I could probably blinky here. So actually pin 7.toggle. Just so we don't have unused stuff. So then jump back in here. What is init show chip info doing? It's not setting up any global state or anything like that, just getting some sizes, printing. Okay. Okay, let's try this. So this is the most simple version of creating a new thread and running it. A new task, as FreeRTOS calls them. Huh. All right. Oh. Yeah. Okay, so that works fine. Cool. So I guess maybe let me move Wi-Fi. Let's move Wi-Fi to right before we jump into the forever loop here. Okay. Where is... There. Show chip info. There's the Wi-Fi. Before we do that, show more chip info. And then this initialize SMTP service. It's gonna wait at least 10 seconds. Oh, could it be the set end? This, I think it might be this. That's like blowing, if what's happening is it's blowing out the RAM, then I'm gonna need to figure out how to run the debugger and inspect some variables, which is cool. I mean, it's cool when you get it running. It's not so cool to get it set up, depending on how annoying they've made it. Although I think it supports OpenOCD. Yeah. Okay. App main, initializing, display comms. Wait. There we go. Display comms, resetting probe. Initializing Wi-Fi. And then 6656 for the driver task. Program counter is at, I assume, not an unreasonable address. It also doesn't, oh, core 0. Yeah, I'm assuming it's all core 0 right now. Because I think core 2 is the RTC core. Oh. Task wrapper. Okay. Huh. Can we use to generate measuring static sizes? Range of heap APIs for measuring free heap. Heat measurement. Measuring static sizes. Sure. Oh. Oh? Oh. Yeah, I mean... What if I don't do these? Let's skip that set env and whatnot. Adjustment. Don't care. Still the same kind of error? Oh, today's been a failure. At least so far. I got another half an hour in me. And then I gotta make dinner and feed the cat. I have to figure this out. What is going on? What is going on? What's happening? Okay. This is the other core. Is that core 1? The real-time core? And then what's the difference between RAM and DRAM? And we got 2 RAMs. Is that really that much more than that? So let's see. Calculator. OX, where'd it go? OX, 3CF whatever plus OX 467B8. And it's not going to do the math for me. Calculator. Programming. We're going to do this value. We're in hexadecimal. Yep. We're going to add this value. Get rid of the zeros. So I don't know if that does anything, but here we go. And we get a 3 FCE 9710. That should be, so that's contiguous there. And then if we add another 5724, that's 3 FCE 34. Not quite, but it is, so 3FCF would be the next thing. 3FCF, which means it's not that far off of like a reasonable boundary. But how much is that? So if we do 3FCF 0, 0, 0, 0, 0 minus, we got 1, 1, and if we do decimal, we'll see about 4K off the edge. Okay. How do we do DRAM then? Determining stack size. Yeah. Enabling new nano formatting reduces stack usage of any calls, any task that calls printf. And then I am making some poor decisions elsewhere. ESP log I. ESP log level local ROM printf. Wait, where's the here? If ESP log enabled, ESP log level. Okay, ESP log level. Wait. Yeah. Where'd it go? Where's it defined? Here. Config log timestamp. Oh yeah. Let me menu config this so that I can disable all this printing, and hopefully that doesn't kill, or hopefully that fixes how we're getting killed here. Where is it? Build type? No. Partition table. That's fine. Component config. ESP. There should be a log somewhere. I don't see it. Application level tracing. Here we go. No? That's not it. So what the heck? Common. Am I missing it? Driver. Is it common? No. Oh boy. Ethernet, event loop, GDB, HTTP server, power, system settings, CPU frequency, RTC fast memory. I don't want a 0 here. Let's do 5 seconds. If it panics and then it doesn't destroy everything. But nothing on the logs. I want to turn off the logs. Log. Aha. Log level. Default verbosity. Errors only, please. Max verbosity. Same as default. Enable global master log level. No. Log tag cache size. What is that? 31 bytes? Not sure what that means, but I'm gonna quit. Save. And then flash and monitor. Come on, don't crash on me. I have to build the whole thing because I ran menu config. It touches way too many things, I think. I guess maybe everything logs. We'll see. Come on. So if you're just joining me, I'm trying to get this device powered with an external power supply that is meant to simulate a battery. So batteries, I'm going to use a 9-volt battery. This thing does not run on 9 volts. It runs on 3.3 volts. So I've got a little chip here that knows how to take 9 volts or whatever. It's got a range. And then on the other side, you get there's a little knob you can turn on this guy. Hard to see Kind of small, especially in this view. But you can tune the knob and out comes 3.3 volts or whatever it is. Yeah, so still getting this guru meditation error. So let me... Where else am I using printf? I'm not using it anywhere in... Once I'm like in one of my system things. Except for here. ESP... Let's see, log I, or let me do this. Get rid of this whole function. And then if that doesn't help, I'm gonna get down and dirty with the debugger. This is my suspect. All this environment variable and time zone stuff. Yeah. Log info. Tag is, find it here somewhere. It's just Wi-Fi service. Did it work? No, it did not. Oh, it did. It did? That's incredible. Whoopsie. Okay. So is this thing blowing out my stack? Okay. Then this one I want ESP log E tag failed NTP comms? I don't know what to call that. So we'll get rid of that. And then maybe I just need to give my main thing more stack. So let's do that. Close that out. Let me put back. Oh, come on. Main CBP. Put back the toggle in the LED toggle task. Yes, instead of a null pointer, we pass in a pointer to our GPIO pin. I'll keep this disabled, but then I'll also plug back in all the other stuff. Okay. So that should get us blinking. Assuming it doesn't crash. Because the stack is definitely big enough for that little blinky thread. Like, doesn't do anything. A few stack frames. Wait. Panic abort. Block next. TLSF block functions. Load cal. What the heck? Okay, that's this is very different from what was happening before. Why did it work before? I don't understand. It might be debugging time. Okay. Alright, so that's no longer failing the probe. I guess it wasn't really doing that before. It was. For the display. But then it was failing the probe. Weird. Something with pull-ups, maybe? I don't know. Okay. Rebooting. We got some stuff. Boot. All the things. Boot, boot, boot. Wait, this is I. I should be... I is info. I don't want to see info. I thought I turned all that off. Type ST. Length. A lot of stuff in here for Wi-Fi data. Sure. I got 2 megabytes of flash. That's like infinite flash. So why is the guru erroring out in its meditations? I've turned this off. So, okay. I suspect that if I disable the Wi-Fi, we're gonna have like no problems. Let me first try disabling all the prints. The print statements. All but maybe 1. Don't need that. Don't need that. Chip info, that should stay. Oh. Okay. This does not actually do anything. That's good. Starting with shot measurement failed. Get rid of that. And for now, don't want to see this. And this is old placeholder, so that can go away. Get rid of this. And run it again. Flash. Kind of bummed out this isn't just working. Okay. Okay, so we go from quite a bit of heap space to slightly less heap space before we call initialize Wi-Fi. So writing to the instruction register, is it because I'm putting this in here? Let me do this. This should be, first of all, it should be const. It should also be static. So that should be easy. To pull out a RAM. What just happened? Okay. And then sprintf. Sprintf is probably kind of expensive, but I don't think it's gonna be cheaper to build the string by myself, because there's floating point, which is what takes up all that takes up a lot of space. So maybe that could be the reason. So if we skip upload measurement, and then I'll take a look at my other stuff. I think I was kind of careless with buffers on the stack. Or not really, but I mean, no more than like this would take up space, right? You have an 8 byte array. You can say, okay, well, how is that different than an 8 byte struct? You definitely don't want a variable sized array on the stack. That is a recipe for disaster. Yeah. Still on the Wi-Fi problem. So it's just the Wi-Fi service itself? I think that's what's causing the problem. Something about the Wi-Fi service is causing it to crash in a way that I don't understand what it's trying to tell me about why it's crashing. Load store error. Well, let me look that up then. Load store error. Does that mean it was trying to execute? Well, let's see. It was trying to execute random memory. You use string class when creating character arrays on the fly. Are you using delay? Creating target is for memory fragmentation. Yeah, I mean that could be a problem, but I don't think I'm not doing any heapage anywhere around here. None of this is heap stuff. This is all. I mean, I'm assuming unless these built-in functions are using heap without telling me. I don't think they are. So that's fine. Got GPIO pin. He's not complicated, so that's not the problem. HTTP client. That's only called as part of upload measurement, so that's not even getting called. Don't need to worry about that. I do see bus. Sure. That looks fine. Display. This is... Oh, this shouldn't compile. I think. Why does it compile? Yeah, this doesn't seem like it should compile because I'm putting in a value into a static array. Let's see, 1, 2, 3, 4, 5 bytes here. So this should just be that. Construct an array of 5 elements and transmit it. Right? 1, 2, 3, 4, 5. 5 bytes. 5 bytes. Pass it. So that should be fine. I mean, I shouldn't be... I shouldn't be so on the edge that 5 bytes makes a difference. So here are 2, just to be clear, 2 bytes. There's a buffer on the stack. That should be okay. 3 bytes there. 6 bytes there. Two. I mean, what else? What else is there? I am still really... I'm dwelling on why static const this was allowing me to do what it was doing. I suspect it might be the first time it came in, it would take the value and stuff it in, and then it would just grab data bytes. That must be what was happening. I'm skipping this track. Okay. Is that run? We'll do flash and monitor. So that's not gonna fix my stuff. If the problem is Wi-Fi somehow crashing everything, but is it Wi-Fi or is it me and how I'm using Wi-Fi? So I've turned off this NTP stuff. Not even gonna worry about it. This is just doing errors here, and I never got an answer to what does it mean load store error. LSP or ESP32 load store error. Oh. Cannot be continued in a well-defined way. Those are the load store prohibited error double exception. Is that different? Panic handler. Illegal instruction exception was unhandled. So the system level checks. I don't know why there's a apostrophe there. Panicked is a word. DF monitor, program code locations. No. Guru meditation errors. All right, here we go. Not either of those. This one. If the application has attempted to do an 8 or 16-bit read to or write from a memory region with only supports 32-bit reads and writes. I have not done that at all. If the application has attempted to write to a read-only memory region, such as IROM or DROM. I don't think I've done that at all. I don't understand. Is there... Load store error. Did I read that? Yeah, load store error. If the application has attempted to do an 8 or 16-bit read to or write from a memory region with only supports 32-bit reads and writes. For example, dereferencing a char star pointer to instruction memory will result in such an error. But it's not in my code. I don't think. Okay, so let's do this. Stud puts a... Well, we'll do netif init pound include C studio, and then I think the first conceivable place where it could be my fault. So I give it the Wi-Fi event handler, which is a function here. It's a static function. It's a static member function, so it doesn't need... It doesn't have a this argument. Which is fine. That's what I'm using arg to do. So this should be a pointer called self. And I mean, okay. What's getting me is that this worked. This was working. So unless I'm doing some kind of... I've overflowed somewhere or something, then this should be fine. I don't see how I'd overflow. Maybe I'm too optimistic in how small the task here is. But like, I don't know how much smaller you get than whatever that is. Right? Call VX X task delay until X task delay until. Oh my gosh. X task delay until is not implemented in the... Oh. It's not implemented here. This is an H file. Oh, bloody hell. Applications. ESP. What was it called? X task delay until. I'm looking for a this tasks.c. Let me make this readable. What's that? Okay. X task delay until Couple bytes, couple bytes. Trace. Some assert, suspend. I mean, nothing jumps out at me as like, this is gonna take tons of stack space. So maybe that's all the problem that I have. So how many words do I need though? So we'll do 512. There. And then is there a way that must be with menu config to set the main task the stack size for the main task? Oops. No, come on. What is happening? Okay. Boot ROM, flasher, partition table, component config. Let me just look this up. Nano formatting, reducing task count, internal stack sizes. Some are created during startup. Default usually set conservatively high. Many are configurable. Running the main task as stack size config ESP main task. Found in component config system settings. Okay. Component config. ESP system settings or just system settings? ESP system settings. Memory. No. Back. Memory protection. Sure. Event queue size. Main task stack size. Oh boy. Do we make that bigger? 4096. And actually, I don't think I can scroll in this buffer right now. But maybe is it the event loop that's going bad as well? Here, scrolling up, there's a backtrace of sorts. Okay. There's a task, ioctl, init process, Wi-Fi, NVS init, get U8. Now remember, it was saying that this means one of two things. We're doing an unaligned read, as it were, or trying to read from the wrong place. Wait, so then NVS handle something, read item, find item, find from a hash list. Stern copy. Vport task wrapper. What? Wait, whoa. But then what's it doing? What? Who's doing a stern copy? Is this more of the same stack trace? Report task wrapper? I mean, that's this. Uh... Vport task wrapper. I really don't understand. Are these like stack frames? These are different lines. Okay. Time to look more deeply at the NVS thing, I guess. What is this? Okay, NVS. And I want... Here we go. NVS. Not encryption or anything like that. Embed TLS. This is a huge page. Okay. List of available options by convention. App build type. Whoa, 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 whoa. We've gone way too far. Oh. Okay, so this is just for config of NVS. Where'd it go? Here. Config MVS. Enable encryption. No. Default value, yes. Oh no, I don't want that. Probably. Well, we'll leave it off or on. We'll leave it default. Config, pre-encryption, assert error check, legacy dupe keys, allocate cache, security provider, protection scheme. Oh boy. Then we're open thread. Okay, so not exactly what I'm looking for. I'm looking for... Oh, come on. NVS. Storage library? Oh, corrupted. Well, let me, I guess, Google some of this. So, load store error, NVS flash. Load store error, NVS flash, ESP32. Wi-Fi? Wi-Fi crash NVS related. Low devices. Flash enabled. Illegal instruction. Not what I'm having. It's a value to someone. What? And make SPI flash driver. Enable spy flash ROM driver patch functions. Okay. I guess let's try that. Why not? Component config SPI flash driver. Component config. There's that SPI, but that's not what it said. SPI flash driver. And then enable SPI flash ROM driver patched functions. That's on. So that's not it. Oh well. there's the library. Okay, what is this? Trying to dynamically configure access points. Start with a smart config. Try to build from there. Unable to load from pre-existing API. Easy Wi-Fi restore. It might be better read as Wi-Fi restore defaults. Oh. The purpose of ESP Wi-Fi restore. So maybe I didn't read the Wi-Fi stuff good enough. Let's see. When we start, enable this. This should mean that this gets called later. And then connect. Wi-Fi set config. Well, I guess I don't know why it's doing anything with non-volatile storage. I guess this should be an E. And this should be an E. Error? Warning. I don't know. What is this an example of? Real-time stats? No. I want an example of Wi-Fi. Wi-Fi getting started. Well, that's what I copied. I did what they do for this guy. And I guess that's not correct. Or something. Yeah. Connect. Wi-Fi config. Let's see. Wi-Fi service. I'll put you over here. Compare. Okay. Your lines are too long. All right. That's fine. Init station. Create the event group. Bloody hell. Here. Create the event group. This is set to static, but it doesn't have to be. Unless that's passed somewhere. Wi-Fi event group. No, that's fine. Netif init. Event loop create default. Then create default Wi-Fi station. And then start with the default config. Ooh. We don't do a ESP error check here. And we've also got any ID of instance, an IP address. Make sure those are passed in, actually, because that's easy to miss. Wi-Fi event, any ID, event handler, which it got from... That's the name of this function. Got it. It's the name of the function. And then we're passing in something, but this is just a parameter for use of the handler. So that's correct. So any ID, handler, instance any ID. Similarly, IP event, got IP, the same event handler, the same parameter, but then instance got IP. Then for the Wi-Fi config, C++ doesn't like it when you leave stuff uninitialized. So this is all the same but initialized. SSID pass, threshold, SAE mode, and then this H2E identifier. then Wi-Fi set mode to station, interface station, giving it the config, and then later on, get another call here, ESP Wi-Fi start, should do an error check. Error check. And then I don't know why it's printing init star finished. I guess it's sort of done, because then it's just waiting. So it's not done, but not done, but it's waiting. Group wait bits on the Wi-Fi event group. These 2 bits. False. Well, let me make sure. PD false, I think, is just false. If it's not, then I deserve everything that's coming to me. Port max delay, sure. ESP log I tag Wi-Fi connected to a Wi-Fi AP. AP is short for access point. Failed to connect to Wi-Fi AP. Failed to connect to AP. ESP log E. Unexpected event. And then connect is just a wrapper for ESP Wi-Fi connect, which I assume assumes a default thing because we're not telling it which anything to connect. So there must be something behind the scenes going on, which is not encouraging because something behind the scenes is failing, and I don't understand why. Now, let me do. Since the problem is related to this NVS stuff, walking through what it's doing here, flash init, no free pages, new version found, that's fine. Flash erase. If it, well, this macro would do, if it's an error, so if it's not okay, it would crash. So in this case, if it goes here, then that's because ret is okay before going in here. And then it calls this. Then we return ret. So try it again after erasing. Okay. Config log max level, default level. If you only want to open more logs in the Wi-Fi module, you need to make the max level greater than the default level and call log set before Wi-Fi init to improve the log level. I don't want that if it's it's crashing all my stuff. I don't want that. I don't know. Let's see. We're calling this init show chip info. So get rid of some of these. Keep the first one around. Then get rid of all but the one that happens right before initializing Wi-Fi, and then the one that happens. I meant to do this one. Nah, menu config. No, that was a mistake. Q. IDF Pi Flash. Nope. Flash. Flash monitor. Ah. What disappointing turn of events here. Trying to remember why I'm even doing this, and it's because I wanted to run a Blinky task, and that's it. If I didn't add a Blinky task, this wouldn't be an issue. Yeah, nothing looks out of sorts anywhere. Oh, oh, excuse me. Now we're talking. A stack overflow has been detected. Hell yeah. Why? How much stack do I need? Let's see. Is there a way to measure ESP32 IDF measure stack depth? Is it magical? No, not that. I want to do that get high water mark, I guess. Okay. So let me do... Well, okay. This reference is going to be a word. Right? A word is 4 bytes. And then if I add that to tick type, which is also 4 bytes, that's 8 bytes. Another tick type, that's another 8 bytes. Or it's another 4 bytes, so 12 bytes. And then we're in a loop we call vtask delay, which is a stack frame. So I guess I need way more of these. Is this words? Access create stack depth in words. I don't know. 1024? 1K? This fixes everything. I'm going to be quite happy, but also kind of annoyed. Because how are you supposed to know? Where'd it go? Yeah, we're calling this function, which is just a stack frame, which stores the return address. There are no parameters. Oh, there is a parameter. There's a word that's a parameter. There's an implicit GPIO pin star this right here. So that's just another word plus another word, so another 8. Then we call GPIO set level, which is another stack frame, which is 2 words, I think, plus a word for the return address, plus a word for the return value. So another 4. It's not adding up to 512 in my mind, but okay. All right. I put some of this back. Shoop boop a doo boop 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 boop. Okay. This GPO task. Blah 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 blah. Wi-Fi. I'll put back SNTP service because I think that was working. Apparently. All right. Kill this. Reset and then put back upload measurement. Upload measurement. Okay. Is it gonna work? Every 2 seconds, it should turn on and then back off. On and then back off. So that's working. Now, for the actual test that I wanted to do, it was to do, like, turn this off. Disconnect it, and then power it with the power supply. There we go. Helps if it's connected. And then actually I could switch this back to the workbench display. And put my face back in there. Okay. So it's not exactly working. It is powered on. What if I just reset it? I'm going to try that. Uh-huh. It's working. Look at that guy. On. 1,002, 1,000. Off. On. Every 2 seconds. We blinking. And it's just plugged into the power supply. So this is exactly what I want. This is exactly where I wanted to be several hours ago. Or a couple of hours ago. Yeah, so unfortunately, I can't go much further on this. Tonight, I gotta stop. But, next time, on Thursday, I will be going through and starting to measure how much it's actually consuming. I will take off the LED and I'll take off the display because they don't need to be here. They don't do anything. They just waste battery if I'm not looking at it. So yeah, so today was kind of cool. We took power from this unit, piped it in here to this device right here. And then this device, we tuned it with that little, you can kind of see it here. The little, like, you see that, like, dot in there? That's like a screw. Turn that to tune it so that the output of it is 3.3 volts roundabout. And then that's powering this guy. 3.3 volts. Okay. Well, I've gone like half an hour over. which means my cat is probably super hungry. But yeah, if you're just joining me, you missed out. We did some debugging. So it turns out my stack was way too small and we were blowing it. But yeah, so Thursday I will hook up this up like an ammeter instead of a voltmeter and start getting some measurement for how much current this thing is actually consuming and try to get it down to something reasonable, and then start optimizing its like wake cycle to get that powered properly. All right. Well, that is it for today. Thanks for watching. If you're watching, hey, thanks. I don't know how to say your name. Bug-ina. Thanks for watching. Thanks for hanging out. Thanks for tolerating me, I guess. And yeah, next time we'll have some low power thing, and I'll probably end up hooking up a battery. If not Thursday, then on Tuesday. And I'll catch you next time. Thanks.